Imagine a voyage through the vastness of space, where a spacecraft dances with the gravitational pull of a giant planet, capturing images that take our breath away, or a daring mission to land humans on a distant red world littered with the wreckage of past explorers. These are not just dreams, they are the real stories of NASA's Juno mission to Jupiter and the audacious plans to conquer Mars. Buckle up as we dive into a cosmic tale of discovery, danger, and the relentless pursuit of answers to questions as old as the stars themselves. From Jupiter's enigmatic core to the perilous Martian landscape, this journey will captivate you, spark your curiosity, and keep you hooked until the very end. Let's embark on an adventure that stretches across billions of miles and billions of years, revealing secrets that could redefine our understanding of the solar system. On July 4th, 2016, after a 5-year, 1.7 billion mile trek through the solar system, NASA's Juno spacecraft arrived at Jupiter, the largest planet in our cosmic neighborhood. This wasn't just a routine flyby. Juno was about to get up close and personal with a gas giant 500 million miles from Earth, a stormy world of swirling clouds and crushing pressures. As Juno angled its high-resolution camera toward Jupiter's turbulent atmosphere, the images it sent back were nothing short of jaw-dropping. Picture this: vibrant bands of clouds, swirling storms the size of Earth, and colors so vivid they seem painted by a cosmic artist. These were the closest ever views of Jupiter, revealing a planet that's as beautiful as it is mysterious. The images weren't just pretty pictures, they were a love letter from a distant world, inviting us to explore its secrets. Scientists and enthusiasts alike gasped, "Oh my gosh, look at this!" as Juno's snapshots unveiled a magnificent mosaic of Jupiter's dynamic surface. The beauty of these images alone is enough to keep you glued to this story, but Juno's mission was far more than a cosmic photo shoot. It was sent to peer into the heart of this gas giant, to unravel mysteries that could rewrite the history of our solar system. Jupiter, with its massive size and swirling storms, has long puzzled scientists. One of the biggest questions: does it have a core? You'd think a planet so colossal, 11 times the diameter of Earth, must have a solid core like our own planet, but Jupiter, it turns out, might be playing by different rules. Juno's mission was to find out, using a clever trick: gravity. As the spacecraft orbited Jupiter, it sensed tiny variations in the planet's gravitational pull. These subtle tugs revealed clues about what lies beneath the clouds, like a cosmic X-ray. Imagine Juno speeding around Jupiter at breakneck speeds, feeling gravitational spikes as it passed over denser regions. Engineers back on Earth meticulously tracked its velocity, asking, how fast is it moving now? And now, by mapping these changes, they built a picture of Jupiter's interior, revealing something astonishing: a core that's not quite solid, not quite liquid, but something in between. A fuzzy core. This wasn't the rocky, metallic core scientists expected, like an avocado pit, but more like a bowl of cosmic chili with hydrogen and rocky material blended together in a strange, fluid state. This discovery sent shockwaves through the scientific community, forcing us to rethink everything we thought we knew about how planets form. Juno's findings about Jupiter's fuzzy core didn't just raise eyebrows, they demanded a complete overhaul of our theories about the gas giant's birth. If Jupiter has a solid core, it might have started as a rocky planet like Earth, growing larger by gobbling up gas. But a fuzzy core suggests a different story. Jupiter may have skipped the rocky phase entirely, forming directly from a cloud of gas and tiny pebbles less than an inch wide, strewn across the early solar system 4.6 billion years ago. These pebbles, like cosmic building blocks, clumped together to form a massive core 20 times the mass of Earth, setting the stage for Jupiter's insatiable growth. As Jupiter grew, its gravity became a cosmic vacuum cleaner, pulling in nearby gas and even the cores of other would-be planets. This chaotic feast mixed rock, gas, and pebbles into the fuzzy core we see today, trapped beneath thousands of miles of thick clouds. This discovery doesn't just tell us about Jupiter, it's a key to unlocking the story of our entire solar system. If we can understand how Jupiter formed, we can piece together how the other planets, including Earth, came to be. Juno's revelations are just the beginning, and the mystery still lurking in Jupiter's depths will keep you on the edge of your seat. Jupiter isn't just a pretty face, it's a beast with a dark side. Its environment is one of the most hostile in the solar system, thanks to an incredibly strong magnetic field that traps and accelerates deadly particles. Juno, caught in the middle of this cosmic storm, braves radiation levels that could fry most spacecrafts. This magnetic field, thousands of times stronger than Earth's, creates a vicious environment that makes Jupiter both a fascinating subject and a dangerous destination. As Juno's instruments dig deeper, they reveal not just the planet's core, but also the violent forces shaping its atmosphere and moons, hinting at even more secrets waiting to be uncovered. Getting to Jupiter was no small feat. Launched in 2011 aboard an Atlas V rocket, Juno embarked on a billion-dollar mission to unravel the gas giant's mysteries. The journey was a gauntlet of challenges: violent temperature swings, a treacherous asteroid belt where a single speck of dust could spell disaster, and the need for extreme precision to navigate the solar system. Juno hurtled toward Jupiter at a blistering 165,000 miles per hour, one of the fastest spacecraft ever, but speed was only half the battle. Juno had to slow down just enough to be captured by Jupiter's gravity without crashing into the planet or drifting into deep space. Entering orbit was like shooting a basketball from London to New York and having it balance perfectly on the rim. The stakes were high. A miscalculation could have ended the mission in catastrophe. Yet on July 4th, 2016, Juno nailed it, settling into a stable orbit and beginning its historic exploration. This triumph of engineering and human ingenuity sets the stage for the incredible discoveries that followed, and it's a testament to the daring spirit of exploration that drives us to push the boundaries of what's possible. While Juno dances with Jupiter, another epic saga unfolds closer to home: the quest to land humans on Mars. The red planet, Earth's enigmatic neighbor, has long captivated our imagination, but it's a graveyard for spacecraft. With a 50% failure rate for landings, Mars doesn't roll out the welcome mat. In 2016, the European Space Agency's Schiaparelli lander learned this the hard way, crashing into the surface at 335 miles per hour after its parachute detached too early, leaving a dark scar on the Martian landscape. This disaster underscored the brutal reality. Landing on Mars is one of the toughest challenges in space exploration. Mars's thin atmosphere, 100 times thinner than Earth's, is the culprit. It can't provide enough drag to slow a spacecraft, making traditional parachutes ineffective. Unlike Earth, where giant parachutes can gently lower a craft, Mars demands creative solutions. NASA's Curiosity rover landed in 2012 used a revolutionary sky crane system with parachutes and retro rockets. But for human missions, the stakes are higher. A human lander, weighing far more than Curiosity's 2,300 pounds, needs new tricks to touch down safely. The thin atmosphere, combined with swirling dust storms that can engulf the planet, makes Mars a formidable foe. Why is Mars's atmosphere so thin? The answer lies in its distant past. 4.5 billion years ago, Mars and Earth formed from the same cosmic materials, but Mars's smaller size, about 1/10 Earth's mass, doomed its atmosphere. Earth's molten core generates a magnetic field that shields our atmosphere from the solar wind, a stream of charged particles from the sun. Mars, however, wasn't so lucky. Its core cooled and solidified billions of years ago, shutting off its magnetic field. Without this shield, the solar wind stripped away Mars's atmosphere, leaving it a barren desert. This loss of atmosphere isn't just a historical curiosity, it's a daily reality. Mars loses atmosphere every second to the solar wind, making it a harsh environment for future explorers. Dust storms fueled by the thin atmosphere can block sunlight, cool the surface, and whip up winds that drive massive storms. NASA's Opportunity rover fell victim to one such storm in 2018, losing power when dust blocked its solar panels. For human missions, these storms pose a deadly threat, and NASA must find ways to protect astronauts from Mars' unforgiving climate. To land humans on Mars, NASA is exploring radical new ideas. One concept involves using the thin Martian atmosphere in a unique way, entering at high speed, diving toward the thickest part of the atmosphere near the surface, and then gliding horizontally to bleed off momentum. At the last second, the craft pulls up, using friction to slow down, and descent engines fire for a soft touchdown. It's a daring, almost crazy plan, but as NASA engineers say, sometimes you have to think outside the box. Current plans for human landings remain on the drawing board, but each innovation brings us closer to setting foot on the red planet. Back at Jupiter, Juno's discoveries about the planet's core shed light on its rapid formation. Planets like Jupiter had to form quickly, within 4 to 5 million years, before the young sun's violent radiation blew away the gas in the protoplanetary disk. Traditional models suggested planets grew slowly by colliding with large planetesimals, but this would take too long. Enter pebble accretion, a game-changing theory. Tiny pebbles, less than an inch wide, littered the early solar system. These pebbles, drawn in by a growing planet's gravity, allowed Jupiter to build a massive core in record time. This feeding frenzy enabled Jupiter to grow 1,000 times faster than expected, gobbling up pebbles and gas to become the solar system's largest planet. But there's a twist. If pebble accretion were too efficient, the solar system could have ended up with hundreds of Earth-sized planets instead of a few giants like Jupiter. The key lies in competition. As Jupiter grew, its gravity bullied smaller neighbors, starving them of pebbles and ensuring its dominance. This cutthroat cosmic dance shaped the solar system we see today, and Juno's data continues to refine our understanding of this epic story. While Jupiter and Mars steal the spotlight, our moon holds its own secrets. In 2018, scientists studying data from the Lunar Reconnaissance Orbiter uncovered evidence of the moon's violent past. Dark patches on its surface, known as lunar seas, aren't oceans but vast fields of ancient lava. 3 billion years ago, massive volcanic eruptions flooded the moon with 200,000 trillion cubic feet of lava, enough to cover the United States a quarter-mile deep. These eruptions also released 10 trillion tons of gas, including water vapor, creating a thin atmosphere that could have supported liquid water. For a brief window, the moon might have been habitable, with pools of water and a thin atmosphere trapping warmth. Could life have existed there? It's a tantalizing possibility, but the moon's small size doomed its atmosphere. As volcanic activity ceased, its weak gravity couldn't hold onto the gases, and the water vanished into space. By studying lunar rocks from the Apollo 15 mission, scientists discovered another surprise. The moon had a magnetic field 1 billion years ago, long after it should have faded. This suggests the moon's molten core lasted longer than thought, adding another layer to its mysterious history. Earth itself is no stranger to cosmic drama. Our planet hurtles around the sun at 66,000 miles per hour, covering 1.6 million miles daily. But this orbit isn't static. It stretches and contracts over 100,000-year cycles, influenced by the gravitational pull of Jupiter and Venus. These cycles can trigger ice ages, like the one that buried New York under glaciers 18,000 years ago. Even more dramatic, Earth and the entire solar system are racing around the Milky Way at 537,000 miles per hour, completing a lap every 230 million years. This galactic journey isn't a smooth ride. The sun bobs up and down through the Milky Way's plane, taking Earth through different galactic neighborhoods. Some of these regions may harbor dangers, like dense clouds of gas or stellar explosions that could trigger extinction events. Over Earth's 4.6 billion year history, 95% of all species have been wiped out in mass extinctions, and our galactic orbit might play a role. Understanding these cosmic cycles could help us predict future threats and protect life on Earth. Saturn's moon Titan offers another glimpse into the solar system's diversity. Larger than Mercury, Titan boasts a thick atmosphere and lakes of liquid methane, making it eerily similar to Earth. The Huygens probe, launched from Cassini in 2005, revealed a landscape of mountains and rivers carved by methane rain. Unlike Earth's water-based life, Titan's extreme cold, 290 degrees Fahrenheit below zero, suggests the possibility of methane-based life. The ALMA telescope detected vinyl cyanide in Titan's atmosphere, a molecule that could form cell membranes in such frigid conditions. With 10 billion tons of vinyl cyanide in Titan's lakes, there's enough material to create billions of hypothetical creatures. Could Titan host alien life? The idea challenges our Earth-centric view of biology and expands the possibilities for life in the universe. Saturn's geyser moon Enceladus, with its subsurface ocean, might also harbor life, making the Saturn system a hotspot for astrobiology. As we explore these alien worlds, we're forced to rethink what it means to be alive. Earth's own origin story is a tale of destruction and creation. 4.5 billion years ago, a Mars-sized planet called Theia collided with the young Earth, melting both worlds and ejecting 1 billion tons of debris. This cataclysmic event reshaped our planet, forming the moon from the debris disk and merging Thea's iron core with Earth's. This larger core powers Earth's magnetic field, shielding our atmosphere from the solar wind and preventing us from becoming a barren world like Mars. The moon's gravity stabilizes Earth's tilt, preventing chaotic wobbling and creating a stable climate conducive to life. Without Thea's impact, Earth might not have become the habitable oasis it is today. This cosmic collision, a 1 in a million event, was a stroke of luck that set the stage for life. As we uncover these ancient stories, we realize how interconnected our planet is with the broader solar system, from Jupiter's formation to the moon's lost atmosphere. Jupiter's entourage of moons adds another layer of intrigue to the gas giant story. With over 90 known satellites, Jupiter's system is a miniature solar system, each moon a unique world with its own secrets. Io, the innermost Galilean moon, is the most volcanically active body in the solar system, its surface scarred by hundreds of erupting volcanoes driven by tidal forces from Jupiter's immense gravity. These eruptions spew sulfur plumes hundreds of miles into space, painting Io in vibrant hues of yellow, red, and orange. Juno's flybys have captured stunning images of Io's fiery landscape, revealing a world in constant upheaval, a stark contrast to Jupiter's serene cloud bands. Europa, another of Jupiter's moons, hides a different kind of mystery beneath its icy crust. Scientists believe a vast ocean of liquid water lies beneath its surface, potentially harboring conditions suitable for life. Juno's instruments have detected signs of water vapor plumes erupting from Europa, hinting at a dynamic subsurface environment. These plumes could offer a way to sample Europa's ocean without drilling through miles of ice, a tantalizing prospect for future missions. The possibility of life in Europa's hidden ocean keeps scientists and dreamers alike captivated as we imagine what strange creatures might swim in those alien depths. Beyond Jupiter, Saturn's iconic rings offer a window into the solar system's past. These shimmering bands of ice and rock, stretching over 170,000 miles across, are a cosmic time capsule, preserving clues about the early solar system. Scientists once thought the rings were as old as Saturn itself, formed 4.6 billion years ago from the same protoplanetary disk, but recent data from the Cassini mission, which ended in 2017, suggests the rings may be much younger, perhaps only 100 million years old. This raises a fascinating question. What cataclysmic event created these rings so late in the solar system's history? One theory suggests a moon or comet ventured too close to Saturn and was torn apart by the planet's gravity, its fragments forming the rings we see today. Cassini's measurements of the ring's mass and composition support this idea, showing they're mostly water ice with a dusting of rocky material. The ring's pristine nature and low contamination suggest they're relatively new, a fleeting feature in cosmic terms. As we study Saturn's rings, we're piecing together the dynamic history of the outer solar system, where collisions and gravitational tugs continue to shape worlds billions of years after their formation. Mars wasn't always the dry, dusty world we see today. Evidence from rovers like Curiosity and Perseverance reveals that billions of years ago, Mars was a wetter, warmer place with rivers, lakes, and perhaps even oceans. In 2021, Perseverance's images from Jezero crater showed layered rocks and sediment deposits, clear signs of an ancient river delta. These findings suggest Mars once had a climate capable of supporting liquid water, a key ingredient for life as we know it. The rover's samples, collected for future return to Earth, could hold chemical signatures of ancient microbial life, a discovery that would redefine our understanding of the cosmos. The search for Mars's lost water is a detective story spanning billions of years. Did Mars's rivers dry up as its atmosphere was stripped away, or did water retreat underground, locked in subsurface aquifers? Recent data from NASA's InSight lander, which studied Mars's interior until 2022, detected seismic signals hinting at underground water reservoirs. These findings fuel hope that Mars could still harbor hidden oases, perhaps even sustaining microbial life today. The quest to uncover Mars's watery past keeps us glued to each new image and data point as we inch closer to answering whether we're alone in the universe. The early solar system was a chaotic place, with giant planets like Jupiter and Saturn playing a game of cosmic musical chairs. The nice model, a leading theory, suggests that about 4 billion years ago, the giant planets underwent a dramatic migration, shifting their orbits through gravitational interactions. Jupiter likely wandered inward toward the sun before being pulled back by Saturn's gravity, a dance that scattered smaller bodies like asteroids and comets across the solar system. This upheaval, known as the Late Heavy Bombardment, left scars on the moon and other worlds visible today as craters. This planetary migration didn't just reshape orbits, it may have delivered water to Earth. Comets and icy asteroids, flung inward by the shifting giants, could have bombarded the young Earth, seeding it with the water that fills our oceans. Juno's data on Jupiter's composition supports this idea, showing traces of water and volatile compounds that hint at its interactions with the outer solar system's icy bodies. Understanding this migration helps us connect the dots between Jupiter's formation, Earth's habitability, and the violent history that shaped our cosmic neighborhood, a story that continues to unfold with each new mission. Deep within Earth, 1,800 miles below the surface, lie two massive, mysterious structures known as Large Low Shear Velocity Provinces, LLSVPs. These dense blobs, one beneath Africa and another under the Pacific, are the size of continents and cup the Earth's core like giant hands. Discovered through seismic imaging, these structures defy explanation. Why are they there, and what are they made of? Recent studies suggest they could be remnants of Theia, the planet that collided with Earth to form the moon 4.5 billion years ago. Samples from volcanic hotspots in Iceland and Samoa, which tap into these blobs via mantle plumes, reveal rocks as old as the Earth itself, supporting this cosmic connection. The LLSVPs are more than geological curiosities. They're clues to Earth's violent birth and its unique path to habitability. The Theia collision not only created the moon, but also enriched Earth's core, ensuring a strong magnetic field that protects our atmosphere. Without this shield, Earth might have suffered Mars's fate, losing its air and water to the solar wind. As scientists study these deep structures, they're unraveling the story of how our planet became a haven for life, a tale of destruction and creation that resonates across the solar system. The search for life beyond Earth drives much of our exploration, from Jupiter's moons to Mars's ancient rivers, Europa's subsurface ocean, Titan's methane lakes, and Mars's hidden aquifers all offer tantalizing possibilities for alien life, whether water-based or something entirely new. NASA's upcoming Europa Clipper mission, set to launch in October 2024 and arrive at Jupiter in 2030, will probe Europa's ice shell and plumes, searching for signs of habitability. Meanwhile, the Dragonfly mission to Titan, planned for 2028, will explore its surface for prebiotic chemistry, potentially revealing the building blocks of life in a methane-based environment. These missions remind us that the quest for life is about more than finding aliens. It's about understanding our own origins. Did life on Earth arise in isolation, or is it part of a broader cosmic phenomenon? Each discovery, from Jupiter's fuzzy core to Mars's ancient deltas, brings us closer to answering this question. The solar system is a vast laboratory, and with every mission, we're peeling back layers of mystery, uncovering connections that tie our planet to the stars. This journey of exploration is far from over, and the next breakthrough could be just around the corner, waiting to captivate us all. Venus, often called Earth's twin due to its similar size and composition, presents a stark contrast to our habitable world, offering a cautionary tale about planetary evolution. Beneath its thick, choking atmosphere of carbon dioxide, Venus is a hellscape with surface temperatures hot enough to melt lead, around 900 degrees Fahrenheit, and crushing pressures 90 times that of Earth's. Data from NASA's Magellan mission in the 1990s, and more recent observations by the European Space Agency's Venus Express, which operated until 2014, reveal a planet shaped by intense volcanic activity and a runaway greenhouse effect. Unlike Earth, Venus lacks a magnetic field, leaving it vulnerable to solar wind that stripped away its water billions of years ago, transforming it into the inhospitable world we see today. The mystery of Venus's past keeps scientists intrigued. Was it once habitable, with oceans and a milder climate? Evidence from Venus Express suggests that ancient water may have existed before the planet's atmosphere thickened, triggering a catastrophic greenhouse effect. Future missions like NASA's Veritas and Da Vinci, planned for the late 2020s, aim to map Venus's surface and probe its atmosphere for clues about its lost water and potential for past life. Exploring Venus not only deepens our understanding of planetary climates, but also highlights the delicate balance that makes Earth a haven, urging us to protect our planet from a similar fate. Between Mars and Jupiter lies the asteroid belt, a chaotic ring of rocky debris that holds clues to the solar system's turbulent beginnings. These asteroids, ranging from small boulders to the dwarf planet Ceres, are remnants of material that never coalesced into a full-fledged planet, likely disrupted by Jupiter's immense gravity. NASA's Dawn mission, which explored Ceres and Vesta until 2018, revealed that Ceres has a water-rich crust and possible subsurface oceans, while Vesta's surface bears scars from ancient collisions. These findings suggest the asteroid belt is more than a cosmic junkyard. It's a repository of primordial material that can tell us about the conditions that birthed the planets. The asteroid belt's role in Earth's history adds another layer of fascination. Impacts from asteroids, like the one that likely triggered the extinction of the dinosaurs 66 million years ago, have shaped life on our planet. Today, missions like NASA's OSIRIS-REx, which returned samples from asteroid Bennu in 2023, are unlocking the chemical makeup of these ancient rocks, revealing organic compounds that may have seeded Earth with the building blocks of life. The asteroid belt, far from being a mere obstacle for spacecraft like Juno, is a dynamic region that continues to shape our understanding of the solar system's past and our own origins. Beyond Neptune lies the Kuiper Belt, a vast, icy region teeming with objects that offer a glimpse into the solar system's outer reaches. This distant frontier, home to dwarf planets like Pluto and Eris, is a relic of the early solar system, where icy bodies formed far from the sun's heat. NASA's New Horizons mission, which flew by Pluto in 2015, and the Kuiper Belt object Arrokoth in 2019, revealed a world of surprising complexity. Pluto boasts mountains, glaciers, and a thin atmosphere, while Arrokoth's flattened, snowman-like shape hints at gentle collisions in the early solar system. These discoveries challenge our assumptions about the outer solar system, painting a picture of a dynamic, evolving region. The Kuiper Belt's significance extends beyond its icy inhabitants. It's a source of short-period comets, which occasionally swing into the inner solar system, potentially delivering water and organic materials to planets like Earth. Studying the Kuiper Belt helps us understand the processes that shape the outer planets and the distribution of volatiles critical for life. Future missions to this region, though still in planning, could reveal more about the solar system's formation and the potential for life in its coldest corners, keeping us captivated by the mysteries lurking at the edge of our cosmic neighborhood. From Juno's daring dance with Jupiter to the dream of landing humans on Mars, the solar system is a tapestry of mysteries waiting to be unraveled. Each discovery, Jupiter's fuzzy core, Mars' lost atmosphere, the moon's ancient seas, Titan's alien lakes, Venus's hostile climate, the asteroid belt's ancient rocks, and the Kuiper Belt's icy relics, brings us closer to understanding our place in the cosmos. These stories aren't just about distant worlds, they're about the forces that shaped Earth and made life possible.